6 things happened in AI and science in the last few months that add up to something big. AI systems are now catching errors humans missed for decades. AI agents just reran the biggest machine learning conference on Earth and could only reproduce a third of it. And a separate study found error rates inside published AI papers are up 55% in 4 years. That's the first half of this video, with the actual numbers behind each claim. The second half gets stranger. The 10-year anniversary of the most famous move in AI history, a math benchmark that collapsed in under 3 years, and an AI model that broke out of a sandbox it was never supposed to leave, and emailed a researcher to prove it. All of it in order, starting now. In Hangzhou, a theoretical chemist named Sebastian Pios was using an AI model to predict boiling points for a handful of molecules. The numbers didn't match a reference database chemists have trusted for 75 years. His first thought was that the model was broken, the reasonable reaction when a machine contradicts a handbook. So he pulled the original literature by hand and traced the numbers to their source. The database was wrong, not the AI. Boiling points aren't trivia either. Chemists use them to identify substances and design real equipment, distillation included. Get the number wrong and every process built on it inherits the mistake. Pios's model then flagged 2 more errors already sitting inside the scientific record. A typo in a published paper, and a set of century-old measurements that were simply incorrect, both likely sending other researchers chasing results that were never going to work. What happened next was a company pointing AI at an entire top-tier conference at once, and the number that came back is worse than you'd guess. A research review company called SI Labs took all 168 papers accepted for oral presentation at ICML 2026, the top slice of one of the most selective ML conferences that exists, and set AI agents loose on them. The agents pulled the central claims from each paper, grabbed whatever code and data was available, and reran the experiments to see if the results held up. They fully replicated 105 of the 168 wild papers. Of those, 92 had at least 5 claims specific enough to check. Here's the number. Only 34 of those 92 reproduced more than 40% of the claims attempted. Raise the bar to 80%, and you're down to 8 papers, out of 168 that had already cleared peer review, plus a second selection round on top of that. The run also surfaced 903 code and reproducibility problems human reviewers never caught, and put the median cost to fully reproduce a paper at $8,900 with one running nearly $2.2 million. That's what it actually costs to check whether published machine learning is true. If you think that's one aggressive company with a point to prove, a second, completely separate study lands in the same place, and this one counted actual mistakes, not failed reruns. A team out of Stanford built an AI system to hunt specifically for objective errors in published papers. Wrong formulas, bad calculations, mismatched figures and tables, not subjective opinions about how interesting the work is. They ran it across years of NeurIPS, ICLR, and TMLR. At NeurIPS, the average paper had 3.8 objective errors in 2021. By 2025, that number was 5.9, a 55% jump in 4 years. ICLR went from 4.1 to 5.2, TMLR from 5.0 to 5.5. And this wasn't the AI making things up. Human experts manually checked 316 of the flagged mistakes and confirmed 263 were real, an 83% hit rate. These are papers other papers get built on top of. Every citation that leans on a broken result inherits the crack, and it spreads quietly until someone checks. Before you write off machine learning research as fake, though, there's a catch that might matter more than the headline number. These ICA checkers are not reliable judges on their own. Researchers who study them are blunt. The tools make mistakes the same way humans do, so every flagged error still needs a human to confirm it. One review found that even the best-performing checker caught only about a fifth of the errors human reviewers had already found by hand. And it also threw out false positives, flagging correct work as broken. Plug a system like this straight into publication decisions with no human checking it, and you'd reject good papers while real mistakes still slip through. The honest use case right now is narrow. Point a human towards something worth a second look, not hand down a verdict. There's a whole volunteer effort, the Black Spatula Project, trying to figure out exactly how much these tools can be trusted before anyone leans on them at scale. So that's AI catching what's already broken. What comes next isn't about catching mistakes. It's about AI producing something no human in the room saw coming. 10 years ago, Lee Sedol, one of the best Go players who ever lived, sat down against a DeepMind program called AlphaGo. Game 2, Move 37. AlphaGo placed a stone in a spot no professional player would ever have considered. DeepMind later calculated the odds of a human making that move at roughly 1 in 10,000. Commentators called it a mistake in real time. It wasn't. It took the room a while to even recognize what they were looking at. Researchers later described this exact pattern as an eye trained through trial and error, stumbling into something new, surprising, and genuinely brilliant, in a way that catches even the experts off guard. Demis Hassabis, who co-founded DeepMind, still calls it a watershed. The first time AI produced a genuinely original idea inside a field humans had studied for centuries. That same pattern is now showing up everywhere, and math is the clearest example. In 2023, AI models were still fumbling basic arithmetic. In 2024, DeepMind took silver at the International Mathematical Olympiad, treated at the time as a landmark. In 2025, both DeepMind and OpenAI took gold. By 2026, multiple labs, OpenAI, Anthropic, and others, were landing reported perfect scores 42 out of 42, and it barely made a splash because everyone had already moved past it, with Anthropic's result treated almost like a footnote inside a much larger technical report. Around the same time, OpenAI's system was credited with solving a long-standing open math problem, and Anthropic's with disproving an established conjecture, both for a few $1,000s of compute. Math broke first because it's unusually easy to verify. A proof can be checked line by line. Exactly the kind of problem trial and error training eats alive. Hasabi says the next real benchmark for this pattern is a Millennium Prize problem. And when asked if that's coming, his answer was that he doesn't see a reason it won't. After AlphaGo, human Go players actually got measurably better. There's published data showing professional move quality climbing after 2016. But they also converged, everyone playing more like the machine and less like themselves. And some players, including Lee Sedol himself, said the game stopped feeling the same afterward. Hasabi's answer for where this goes next is what chess did after Deep Blue beat Garry Kasparov in 1997. Human plus machine teams that, for a long stretch, actually beat machines alone. He thinks science is heading into that same phase, and for the messiest fields, drug discovery, biology, chemistry, it could last a very long time. One more detail from that 2016 match is worth knowing. 2 games after Move 37, Lee Sedol played a stone of his own that AlphaGo never saw coming, Move 78. So unexpected the machine fell apart. They called it God's touch. Same odds, 1 in 10,000. AI is going to keep producing its version of Move 37, in chemistry, in math, in places nobody's watching yet. The job now is finding our Move 70. That's the video. Thanks for watching. I'll see you in the next one.